Okay, so the first one here is using the synthetic division. You want to find the quotient in here, right? So synthetic division, the first one right here, we're using x minus 1. We write down equal to x minus c. So my c here will be just 1. Okay, so I have a 1 right here. And then we have a x to the 5 plus 0 x to the 4 plus 5 x cubed plus 0 x squared plus 0 x minus 6. Look at that. Anytime if you have missing term, you have to supply the 0 in here. Okay, so these are equal. So I will have a 1, 0, 5, 0, 0, negative 6. Okay, and then pull the first one down. 1 times 1 is 1. So the good thing is this all doing the addition, right? So we have a 1. 1 times 1 is 1. We have a 6. 1 times 6 is 6. Okay, and then you have a 6 in here. 1 times 6, you still have a 6. 1 times 6, 6. So this remainder is 0. Okay, so that means this whole thing, I can write down my quotient. This will be 1x to the power of the 4 because 1 degree lower than the dividend here. Okay, plus 1x cubed plus 6x squared plus 6x plus 6. All right, so that will be you this division. Okay, the synthetic, using the synthetic division, make sure you supply the 0 for the missing term. Any questions? All right, I want you to go ahead, give you a few minutes. Let's see, go ahead. Can you do this one in here? Give you a little bit practice. All right, so I'm gonna give it like a 3 minutes in here. Can you do the second one on your own? And then we're gonna come back to talk. I would rather let you practice a little bit. Okay, everyone, go ahead, do this one and then try to see if we can find out the answer later. Okay, second one, go ahead and give it a little bit division. Okay, so this one, as you can tell, we don't have a missing term, right? So x cubed, x squared, x, and then the constant. So we don't have a missing term. So I just write down 4, negative 5, 6, negative 3, and my c here is 2, right? And then you do the division. So remainder here is 21. Okay, and then that's how you write down the equation. You have a quotient. 4, this is a quotient coefficient, so 4x squared plus 3x plus 12, and then plus the remainder. Okay, questions? All right, look at number 3 here. Is this one is a polynomial or not? The answer will be yes, because this is power or integer. Okay, so it is a polynomial. And then this is considered degree of 7, the highest degree. Okay, so this is degree of the 7 polynomial. All right. Number 4, is this a polynomial? Of course, the quadratic equation, quadratic is a polynomial of the part of the polynomial, right? Because these power are all integer. Okay. And how do you find the vertex? We reviewed this one last time here, the vertex, right? Since this one do not complete a square, we can write down vertex is negative b over 2a, and then just plug this one into the equation to find the y. So my vertex x here will be negative b over 2a. My b here is 8. My a here is negative 1. Okay, so that will be 4. And then my vertex y will be f of 4, right? My negative b over 2a is equal to 4. So I just need to find the f of the 4. So this is negative 4 squared plus 8 times 4 plus 4. This negative do not have a square, so this is negative 16, 32 plus 4. And that will be giving you 20. Okay, so your vertex here is 4 and 20. That's your vertex. All right. So once you know this one right here, and I'm sure this formula, it is in the one-page formula sheet, right? There's one-page formula sheet you can use for the test. Okay. Number 5, determine the zeros. Okay. What are the zeros? This is already factor for you, right? So the zeros will be each factor into 0. And then if you have x minus 7 equal to 0, x will be 7, right? X plus 1 equal to 0, x will be negative 1. And then x minus 7, this is x minus 7, this is power of 1. So that's r power. So r power, that means at this point is crossing. Okay? And then you have x plus 1, this is power of 2. So this is even power. Even power are called even multiplicity. So this one is touching or tangent. All right. So there's 2 real zeros. Yeah, there's 2 real zeros. It's a 7 and negative 1. All right. And then each one, graphing, touching. That's how you do that. Okay. Depends on the power. If this is even power or r power, I'm sorry. 1 here is r power. So r power at this point will be crossing. Okay. And then 2 here is even power. Even power will be touch or called tangent in there. All right. This one is using the intermediate theorem to show the polynomial has a real zero between the given integers. So what does the intermediate zero theorem mean? Okay, this one means if I do a graphing, okay, like I said, this is a linear. All right, so a linear here, like I said, this is 2, right? And then when before the graph passing 2, this y is positive. Look at it, y here is positive. After 2 here, y here is negative. Okay, so when y changes from positive to negative, when y changes the sign from positive to negative, or even from negative to positive, it's also changing sign. So that means it has a cross the x-axis, or that means y must be 0 at a certain point in order to change it from positive to negative. Okay, and how do we determine this one right here? We can say, let's see, we can calculate this one really quick. we can calculate f of the 2, we can calculate f of the 3. So if we plug f of the 2 in, right, this will be 2 cubed minus 4 times 2, and 2 cubed is 8 minus 10 minus 2. So that is negative 4. Negative 4 is less than 0, right? And then if I calculate f of the 3, so that's 3 cubed. All right, 3 cubed is 27 minus 15 minus 2. So this is 10. 10 is positive. Okay, so I change it from negative to positive. That means between 2 and 3, the graph must crossing the x-axis. So that means there's a 0 between 2 and 3. Okay, there's a 0 between 2 and 3 in here. All right. And you can go to do the graphing. If you don't really know what I mean here, we can give you a graphing, verify that. X to the 3 power minus 5x minus 2. All right, so between 2 and 3, look at that. On x is 2 here, y is negative, right? On x is 3, y here is positive. So yeah, the graphing crosses the x-axis between 2 and 3, okay? Because one is negative, one is positive. So that means it must cross it between 2 and 3. So that is what I mean in here, okay? So it sounds very fancy, say intermediate theorem, but basically just calculate these 2 points and trying to see if it's positive or negative. If you change the sign, that means it has a 0. All right, number A here is, this is a polynomial function, right? It's telling you this one is a polynomial. And how many degree of this polynomial? What's the degree for this polynomial? Anyone can type it in the chat to see how many degree is this one. All right, so this one with degree of the 4, okay? Because if you cover the negative 1 here, you got x. This vector, if you cover the 3 here, you got x. So this one is a degree of 4 polynomial, all right? And it's negative, so this is even, the leading term. This is considered a leading term, right? Leading term here is even power. So this will be both facing up, all right, I'm sorry, facing down, because coefficient is negative. So this will be facing down. All right, coefficient is negative. So leading term is even power, either both facing up or both facing down. This is a here, a sub n is greater than 0. This one, a sub n is less than 0. Since this one is negative 1, so it should be right here. Okay, that is this one right here. The graph x-intercept. Okay, so what are the x-intercept here? X-intercept, that means y is equal to 0. Okay, so when you have this one is 0, you're gonna have a x squared equal to 0, or x equal to 0, or x equal to 1, right? And then this one be x equal to negative 3. So you're gonna have a 3 0 points in here, okay? Negative 3, 0, and 1 in here. That's the x-intercept. All right. And do we have a y-intercept in here? Okay, yeah, you do have a y-intercept, right? So how do you find a y-intercept here? Y-intercept is x equal to 0. So look at that. Negative 0 squared, 0 minus 1, 0 plus 3. Since you have a 0 outside, so times anything will be 0, right? So yeah, this graph will be passing 0 and 0, okay? And then you can, if you do not know, you can put it in a calculator, put this whole thing in a calculator and you can graph them, right? And according to the one we analyzed, this is facing down, right? This is facing down, okay? So this should be facing down in here. And this one, I think the graph, okay? Um, the graph should be look like a D because it does passing the 0 and 0. The reason this one wasn't correct because, let's make it or you can put it in a calculator, right? Make sure you have all these 3, 0, 1, -3 as x-intercept. So we will have a -3, 1, and 0, right? This one is +3, do not have a -3. So this is incorrect. Correct graph should be D, okay? And this is according to our analyzer. And if you really do not know, you can still put this whole thing in a calculator and we're showing you the correct graph, all right? Okay, number 9 here is to find a vertical asymptote in here. Okay, so this one you have to be very careful because this one has a common factor. All right, this x squared minus 100, we will need to factor into x plus 10 times x minus 10. All right, and then these two gonna be canceled out, so you're gonna have just 1 over x plus 10. So your vertical asymptote is only 1 when x plus 10 equal to 0 or x equal to -10. That is the only vertical asymptote, okay? What happened in this one right here, when you have a common factor, it create a hole, all right? If you want to know a little bit more here, it's create a hole at x equal to 10. And then the f of the 10 here, you plug this 10 plus 10. So it's 1 over 20. So your hole here is in 10 and 1 over 20. So there's a discontinuous point in here. So that means when x equal to +10, it's not a vertical asymptote, it's a hole. Okay? Vertical asymptote, when you have a common factor cancel out. So vertical asymptote is only 1 in here. All right? So that's the one you have to be very careful. Okay? A hole corresponding at x equal to +10 in here. Okay, number 10 here, this is just want to find a horizontal asymptote. Should be very straightforward. Horizontal asymptote, since you have a same degree here, same degree, so y will be just a over b. Okay, a and b is the coefficient of this -2 over 7. So y equal to -2 over 7 is the horizontal asymptote. Okay, so that is pretty straightforward in here. Number 11, since this one wasn't in a ascending order, so this is from 3.1, right? And this one is already in a vertex form. Remember, if you have a f of x equal to a times x minus h squared plus k, your vertex here will be h and k. So basically, you compare this form to this form, your h here should be -6, k here it is 3. So your vertex here is -6 and 3. All right, this one is already in a vertex form, so you don't have to calculate. Okay, it's already in the vertex form. All right, that's probably the easiest way. Okay, this one telling you is a polynomial, right? This one is list all possible rational zeros. Okay, so how do you list all possible rational zeros for number 12? All right, we have we have a sub n here is 1, okay? And then a sub 0 here is 18. All right, so we're going to write down this one is P over Q for all possible 0. Remember, this is a sub 0 factor, a factor of a sub 0, right? P over Q, P here is a factor of a sub 0, and then this one is a factor of a sub n. So a sub n is easy. I will just have a plus minus 1, okay? And how do I write down my a sub 0? We're going to have a 1 and 18, okay? And then we're going to have a 2 and 9, okay? And then we're going to have a 3 and 6. And that is pretty much it. All right. So we divide by 1. Everything divided by 1 still equal to itself. So we're going to have a 1, 2, 3, 6, 9, and 18. So that's 1, 2, 3, 4, 5, 6. 6 times 2. We're going to have at least 12 possible zeros. Okay, 12 possible zeros. And depends on the MindNet math. If you can have a plus minus, you can have a plus minus. If you cannot, if the MindNet math do not show the plus minus 1 here, you might have to write down 1 by 1, like a negative 1, 1, negative 2, 2. All right, it's a little bit tedious, but I think the data Pearson, it does letting you write a plus minus, so it will be a little bit easier. The previous version, it didn't allow you to write down plus minus, so you have to list 1 by 1. Okay, and then this one is using the zeros from the B, find the all real zeros. Okay, so what does this one mean? I do not recommend you to do all these 12 zeros, okay? So I will recommend using the graphing and then verify. Okay, so this will be a quick and easy using the graphing instead of doing all the possible zeros in here. So we're gonna graph this whole thing and then we verify. Okay, we have a x cubed minus 2x oh, hold on. All right, and then we're gonna go ahead and do a little bit graphing. Okay, so even we don't see the top, but you can see that's that's 3 real zeros in here. All right, and then if you want, you can go to the table to double check. Okay, so looks like when x equal to negative 3, this is a 0, right? And then when x equal to 2, y is also 0. When x equal to 3, y is also equal to 0. And are these in our possible zeros there? Yeah, we have 2, 3, something like that. This is all our possible zeros. Okay, so I know this is probably a little bit cheating, but if you don't want to do the synthetic division in here, that is okay because you already found the zeros from the graphing. Okay, you already found the zeros. Okay, so x equal to 2 and 3 and then negative 3. These are all zeros. All right. So those if you want to do, or you can use the remainder theorem to check, right? F of the 3, but I usually go ahead and look at the graphing, and then sometimes if it's not an integer, it's very hard to tell. So I usually
I think you're muted.
Huh? You don't hear me? Oh, when did that happen? From what question? I'm sorry, I didn't realize this one muted itself that way. Maybe I clicked somewhere in mute. All right, so from what question is start muting, I can go back. Anyone realize that? From what question? Is it question for how long? Question 11, do we have a sound on question 11? Okay, so can anyone tell me when you didn't hear the for how long? You didn't hear the voice, or just not long ago? Okay, so we are doing the possible zeros for the 12, right? The possible zeros are gonna start from 12 again, okay? So list all the possible zeros for number 12 is using the A over P over Q, okay? And you're gonna have a coefficient of the A sub n. A sub n here is 1, A sub 0 here is 18, right? And then you're gonna factor each one of the 18. So 18 will be 1 times 18, 2 times 9, 3 times 6. And then everything divided by 1. So you're gonna have at least 12 possible zeros, okay? And as I mentioned earlier, if the Pearson minor method allow you to have a plus and minus sign, you can have this one, which is a little bit easier to write. If you do not have a plus and minus sign in the previous version, you will have to list one by one for all of them. Okay, so that's the possible zeros. And then you using the zeros to find any one of them, right? And one thing is, if you don't like to do the synthetic division, you can go to check f of the 2, right? So look at it. This is called a remainder theorem. So if I have a 2 cube minus 2 times 2 square minus 9 times 2 plus 18, and then I can see 2 cube is 8. This one is 8. 18, 18, this cancel out. So this, it is 0. So that means 2 is a factor, right? X minus 2 is a factor, or 2 is a real 0. So the real 0 here will be 2. And you can also do the graphing. We look at the graph. It looks like we have 3 real zeros in here. You can go to the table, okay? If you want a table, you need to hit second graph table in here. Second graph. Ooh, this one got a little bit freeze. All right, my okay, second graph. My second graph didn't work. All right, it worked earlier. Okay. All right, so you can go to the table here, look at the real 0, right? If you can look at the table in here. Oh, here you go. All right, so if you go to the table here, look at it. When x is negative 3, y is 0, right? And then when x is 2, y is also 0. When x is 3, y is also 0. So if you don't want to do the division or you know, you already have a 0 in here, okay? So that's a little bit quick and easy way, or maybe a little bit cheating way, whatever. But that is the one you can find in here, okay? Any questions? And we just manually verify using the remainder theorem, right? The remainder theorem, f of the 2 is 0, okay? If you want to do the synthetic division, we can do that one more time. C here will be 2, right? And then the synthetic, I don't have a missing term here, so this will be 1, negative 2, negative 9, and 18, okay? The synthetic division. All right, so we pull the first one down. We pull the first one down. Don't do anything. So 2 times 1 will be 2. 2 plus this one will be 0. 2 times 0 will be 0. All right, and then negative 9 plus 0 will be still negative 9 times 2 will be negative 18. So yeah, your remainder here is 0, right? So if I want to do the factoring, I do need to do the division, okay? So this one I can write down is x minus 2. That's the divisor, right? And my quotient here will be x squared, okay? X squared plus 0x minus 9, right? And we usually don't have to write down the 0x, so this will be just x squared minus 9 in here. And x squared minus 9, I can do the factoring, factor into x plus 3, x minus 3, right? So actually, I just factor this cubic into a linear factoring, okay? So when x is equal to 2, negative 3, and 3, those are all zeros. All right, so that is this one right here. You can have so many different ways to find the zeros, okay? And the quick and easy way here, probably the graph here. Okay, number 13. This one is inequality, right? The polynomial inequality here. So the polynomial inequality here, this one is less than or equal to 0, okay? We have a polynomial inequality. All right, we find a critical point. Okay, so where's my critical point? We're gonna make it to 0 first. All right, we make it this whole thing into 0, and this one is already factored for you. So you're gonna have a x minus 7 equal to 0. Each factor into 0. So this x will be 7 and negative 1, right? And then I will go to make a, since this don't have a denominator, so this will be can equal to negative 1 and equal to 7 because I have an equal sign here. So that means I need to include those two endpoints. And then this one, you're going to have a 3 interval, 1, 2, 3, 3 interval, right? Write down each interval. The interval 1 will be from negative infinity to negative 1. Bracket, you have to include the negative 1, right? Interval 2 will be from negative 1 to 7, also bracket. Interval 3 here will be from 7 to infinity, okay? And then we're gonna just go to using a testing point to check. All right, so I can check a f of negative 2, right? So plug x equal to negative 2 in. So negative 2 minus 7, negative 2 plus 1. This one will be negative 9. This one will be negative 1. So this multiplier will be positive 9, which is greater than 0. We want to find less than or equal to 0. So that means this interval is not a solution. Okay? And then the second interval between negative 1 to 7, I can using 0 because 0 is in the interval. 0 is easy to calculate. All right, and then this will be negative 7. Negative 7 is less than 0. So yes, this one is the solution. Okay, this is the solution. And then we can have we don't want to use 7 because 7 will be 0. All right, so we're going to using 10. 10 is easy to calculate than 8. Or if you want to use 8, that's totally fine. Any number in the interval, all good. Okay, or you can use 8. All right, so f of the a here will be a minus 7, a plus 1. So that is 1 times 9 is 9 is greater than 0. So this will be a no. All right, so our solution here will be just from negative 7, from negative 1 to 7. This is the solution. All right, so that is the solution set is from negative 1 to 7, and then you just choose the correct graph, right? So you can see A, B, C, D, E, F, G, which one is the correct graph? Negative 1 to 7, okay? That's only one interval, and you also have to use the bracket because it does have an equal sign. Okay, it does have an equal sign here. If you look at the graph G here, very similar, right? No, not that one, not similar. Graph A and F are very similar, but A here is using the parenthesis. Parenthesis, that means not include the ending point. Okay, but we do have an equal sign, so you have to include both ending points. So that's why F will be the correct one. Okay, any questions? Okay, last question here actually is from 3.1. Okay, like I said, this test here is not in a particular order, in a random order here, right? But it's ranging from 3.1 to 3.6. Okay, write down an equation in vertex form of the parabola that has the same shape as this one, as 2x squared, but with this point as the vertex. All right, so what is my vertex form here? Remember the vertex form, we have a f of x using a times x minus h squared plus k. All right, so my h here will be negative 12. My k here will be negative 5. That is this one. This is the vertex. Your vertex here is h and k. So my h here is negative 12. K here is negative 5. This one gonna have a same shape as the graph. So that means my a here will be 2, positive 2. Okay, and it's facing up. So this one is facing up. All right, so basically you y equal to x squared. This is f of x equal to 2x squared, right? Same shape. But this one is moving to the left for 12 unit and then moving down for 15 unit. All right, so this one will probably somewhere right here, but it's still facing up, the same one. Okay, so we're gonna call this is still using f of x, whatever. All right, so this one, the new equation here, is sometimes we're gonna call it g of x basically, but it's still using f of x. That's okay. All right, just using f of x. Okay, so this one will be 2 times x minus h. H is negative, so minus a negative will be plus. Okay, and then plus k. K here is negative, so it's minus 4. So this is your final equation for this graph, but with the vertex as this one. All right, so one thing is you do need to know the vertex form for the quadratic, right? The vertex form a times x minus h squared plus k. And you don't have to get rid of the parentheses because this is exactly in a vertex form. All right, so that is all the review for this chapter 2. You also have a little bit answer at the end, but I just explained it everything here in detail. Okay, and this video, it is recorded